All right, let's dive right in. Today we're talking about something called the hardware lottery. It's this really fascinating idea that gets at a huge question. Why do some brilliant ideas just sit on a shelf for decades, while others seem to explode overnight?
You know, we have this romantic idea about tech and science, right? That the best idea, the most elegant, the most powerful one, is just guaranteed to win. But is that really true? Is it all just about merit? Or is it maybe more like this? A lottery, where an idea, no matter how brilliant, it needs luck. It needs the stars to align, the right environment, and this is the key, the right tools at the exact right time. It basically needs a winning ticket.
Okay, so let's get into it. This idea we're talking about has a name, and honestly, it's absolutely crucial for understanding innovation, especially when it comes to AI.
Here's the core definition. The hardware lottery is basically this. An idea wins, not because it's the best idea out there, but because it just so happens to be compatible with the hardware and software we've already got. It just fits. Meanwhile, other ideas, maybe even better ones, could totally fail just because the right kind of computer to run them on doesn't even exist yet. The paper we're looking at brings up this great analogy, the Anna Karenina principle. You know, from the opening line of the novel? The idea is, for a family to be happy, everything has to go right. But for a family to be unhappy, just one thing needs to go wrong. Well, it's the same for tech. For an idea to succeed, everything has to line up. The algorithm, the software, the hardware. But for it to fail, just one of those things can be off. And for a long time, that one thing was the hardware.
So how did we even get here? To really get why this lottery is a thing, we got to take a little trip back in time to see how computers evolved. Because for decades, the whole industry was moving in one direction, away from specialized machines and toward a one-size-fits-all computer.
And this right here shows you exactly what I mean. On the left, you've got one of the early computers. These things were massive, crazy expensive, and built to do exactly one thing. The program was literally built into the machine. But then, on the right, you see the thing that changed everything, the general-purpose CPU.
And what drove that huge shift? One thing, Moore's Law. That famous prediction that chips would just keep getting faster and more powerful, like clockwork, every couple of years. This completely changed the game and made the whole hardware industry pretty conservative, you know? Why would you spend a fortune building a custom chip for just one task when you could just wait 18 months and a standard, off-the-shelf CPU would be fast enough to do it for you? So everyone standardized. And that, right there, is what set the stage for the hardware lottery.
Okay, so now for the perfect case study. I mean, this is the story that shows the hardware lottery in action better than anything else. The long, long story of deep learning and what people used to call the AI winter.
I mean, look at this timeline. It's kind of wild. The key algorithm for modern AI, backpropagation, people were working on that back in the 60s and 80s. By the 1990s, researchers had the ideas for deep neural networks. They knew what they wanted to build, but they just couldn't. Why? The CPUs of the day were way, way too slow. So this amazing idea basically held a losing lottery ticket for 40 years. And then what happened? A total fluke. A piece of hardware made for something completely different, video games, turned out to be the winning ticket. I'm talking about the GPU. So here's why that was such a lucky break. Think of a CPU like a genius professor who can solve one super complex problem at a time. It's brilliant, but it's sequential. Neural networks, though, don't need that. They're more like an army of first graders who all need to solve millions of super simple math problems at the exact same time. That's called parallel processing. And it just so happens that's exactly what GPUs were built for, to light up all the pixels on your screen for video games. The math was almost identical. Total coincidence.
Okay, so that brings us to the present day, because the massive success of deep learning on GPUs completely changed everything. That whole era of one-size-fits-all is over. Now, the pendulum is swinging back, and swinging back hard towards specialized hardware. And guess what? That's creating a brand new, even higher stakes hardware lottery.
See, Moore's Law is pretty much over. We can't just count on generic chips getting magically faster every year. So what's the solution? Companies are now building their own custom hardware, things like Google's TPUs, that are specifically designed, hyper-optimized, for the exact kind of math that today's AI models happen to use. But, and this is a huge but, there's a really dangerous flip side to this. When we go all in on hardware that's perfect for today's AI, we're basically making it impossible for a different kind of idea to ever get off the ground. Imagine you have a revolutionary new AI concept, but it uses a different kind of math. Well, tough luck. It's going to run terribly on this new hardware. And so researchers might start to, subconsciously favor ideas that just fit the tools they have. We could be locking ourselves into just one path for AI, and that's a huge risk.
And we have really good reason to think there are other paths. Just look at our own brains. It's the only example of true general intelligence we have, and it works completely differently from our AIs. It's unbelievably energy efficient, uses all sorts of specialized local processes. It's nothing like the giant, power-hungry, all-at-once calculations that our current models do.
The paper has this perfect metaphor for it. By just making our current models bigger and running them on bigger, more specialized hardware, it says we appear to be trying to build a ladder to the moon. It looks like you're making progress, right? You're building higher and higher, but you're never actually going to get there. It might be the completely wrong path to real intelligence.
So, this is the big question, isn't it? Can we break out of this cycle? Is it possible to design a future where the best ideas actually win on their own merit, no matter what hardware happens to be lying around today?
And look, the challenge here is just immense. Making a new computer chip isn't like writing some code over a weekend. It's a slow, painstaking, physical process. From the moment you have the design to when you actually have a working chip in your hand, you're talking 2, maybe 3 years. And then there's the cost. Get this. We're talking $30 to $80 million for one chip design. When you have that much money on the line, is it any surprise that companies would rather bet on a sure thing and take a risk on some wild new experimental idea? So what can we do? How do we make this lottery a little bit fairer? Well, the paper suggests a few things. First, we have to find ways to make designing new hardware cheaper and faster. Second, we need more flexible hardware, like FPGAs, that aren't just locked into one way of doing things. And third, we need better software, tools that can help researchers figure out how their new algorithm might run on a type of computer that we haven't even built yet.
And that's really the thought I want to leave you with. This whole hardware lottery thing, it's not just some interesting history lesson. It is happening right now. It makes you wonder, doesn't it? What revolutionary, world-changing ideas are out there today, just collecting dust on a shelf, waiting for their lucky number to be called? How many of today's failures are actually just tomorrow's biggest breakthroughs if only they had the right lottery ticket?